Welcome back to Mammoth Interactive. In this lecture, we're discussing how to build an NFT as a blockchain programmer. We'll learn how to build an NFT contract with Truffle and OpenZeppelin. We're going to build this project locally on our computer, not online on something like Remix. So for that reason, we have to set up the project and everything that it needs on our computer. So we're going to first have to build a new project with NPM. So you will have to download Node.js, which includes NPM. This is a node package manager that allows us to control our project and to use different libraries together in the project. Then we have to open the terminal or command line application. This is a built-in app on your computer that allows you to interface with your operating system. It's called the terminal on Mac or the command line on Windows, also commonly called the console or the command prompt. Right, so here we can see the terminal, the folder that we're currently in, and we can type commands to the terminal and hit enter to submit commands. Why do we want to use the terminal? Well, we can do a lot of development tasks here via the terminal. We can set up our projects, and with Node and NPM, we can install packages, we can run servers and run scripts. So we need NPM and the terminal. Read more at our website. We have a tutorial on top terminal commands that developers must know. It's important for developers to know NPM and the terminal. So then we can build a new project with NPM. So we are going to learn how to create a new folder. So first you have to make a new folder with the command mkdir. But you can also do this manually by creating a new folder. Then you can enter the project folder, same thing as just opening the folder. But then in the terminal, once you're in the folder, you have to scaffold your NPM project. So you can use the command npm init to initialize a new NPM project and hit enter through all the prompts to get all the metadata for the project. So this is setting up an NPM project. As a result, you'll have your project folder with one file in it called package.json. This contains data that describes the project, like what is the name and the version. Right, so now we've been able to create an NPM project. So our next step is going to be to install some tools and libraries that our project will use, starting with OpenZeppelin. OpenZeppelin is a library for smart contract development. So they have a lot of token standards, standardized ways of building coins and NFTs and other contracts. So make sure you're in your project folder in the terminal and then call npm install and install OpenZeppelin contracts. Okay, so this will install the file and the whole library actually. So you'll have a new folder called node modules, which will contain the OpenZeppelin library. You'll also have package.lock.json, which is just a locked version of your package.json file. And now in package.json, we can see that we have OpenZeppelin contracts added as a dependency. Okay, next up we have to install Truffle. You can get Truffle from trufflesuite.com. Truffle is a super popular tool for blockchain app development. It abstracts away a lot of complexities that exist with making blockchain apps. It allows for easy development of dApps, decentralized apps. With Truffle, you can manage your whole blockchain project, the blockchain side, and also even the website or the app side if you have a dApp. You can deploy contracts, develop your apps, and run tests. You can compile your smart contracts, build them in your Truffle project. You can inject your contracts into web apps, and you can develop the front end for your dApps like a website. So we have to install Truffle with the command npm install Truffle. As a result, we'll have a lot of packages added. Truffle is actually quite huge, so we'll have a lot more folders in node modules. And in package.json, we'll have Truffle added as a list of our dependencies. Next, we can use Truffle to create a new blockchain project in our existing project folder. So in the terminal, go to your project folder and call npx truffle init. Right, this command is going to initialize a new project that's a Truffle project in your npm project. This is going to build a contracts directory and a configuration, a Truffle configuration to connect to the Ethereum network. NPX is similar to NPM, but for a local package, like if you have Truffle locally, which means it's only available in your project instead of being installed globally. All right, so now we have more folders in our project. We have a contracts folder to store the smart contracts, a migrations folder to write code that deploys the contracts to the blockchain. We still have node modules and package.json. We also have a test folder where you can put tests to test the project and test smart contracts. And then we have Truffle config, which contains the Truffle configuration to connect to the Ethereum network. So we also get one sample smart contract, migrations.solidity. This is just a sample contract that Truffle has built for us. We also get a sample migrations file. This is just some sample code showing how you can write code that will deploy a smart contract. And as well, we have Truffle config.js, which has a lot of comments showing you how to configure your project for a blockchain. But if you remove all the comments, then really you just have this setup where you can define networks, you can define Mocha tests, and you can define your compilers, like what version of the Solidity compiler. Our next step will be to get or create an NFT smart contract in Solidity. What will be our NFT? We're going to use an NFT preset, which means it's all pre-built for us and ready to go by OpenZeppelin. You don't have to even touch it. And it's called ERC721 Preset Minter Pauser Auto ID. So there's a lot of code that comes together to build this smart contract. But in terms of instantiating the contract or creating the NFT, you just need the name, the symbol, and the base token URI, which is the NFT details. So that will be our smart contract that we'll use, pre-made for us. So next we have to build the contract artifacts. Contract artifacts are useful contract information. So you can take a Solidity file and make it deployable if you make it into a contract artifact, which means you take a Solidity file and you convert it to a JSON file. A JSON file uses human-readable text to store data. So you're representing your contract as JSON data, JavaScript object notation, instead of as Solidity. Right, so we can turn .solidity into .json. Now, OpenZeppelin contains pre-built contract artifacts for us. So for our contract, our NFT, we can actually use a pre-built contract artifact. If you're building your own NFT contract, though, you'd have to generate the contract artifacts by compiling the contracts. Right, so we can take our pre-built contract artifacts made by OpenZeppelin, just copy build/contracts from the OpenZeppelin folder into your project root folder. So as a result, you'll have a bunch of artifacts that are easy to access, including your NFT contract artifact. All right, our next step is going to be to build the NFT metadata. So defining what the NFT details are. You can use pre-made token metadata by going to myjsonserver.typico.com, and we have some metadata that we've already built. Or you can create your own metadata. For that, you need a public repository on GitHub, and we've included an example of a repository, the repository that we're using for this project. Then you have to create a database.json file in the repository. This database.json is going to contain the NFT details. For example, here is our database.json. It defines the tokens, each token ID, description, external URL, and name. So this is the data for 3 NFTs that we're going to create. So you want to follow this format when building your own details. You can find your database.json file from GitHub via this myJSON server, which allows you to interact with your JSON data hosted on GitHub. So it's a handy website that allows us to store our NFT details on GitHub and then access them via the JSON server. You can visit myjsonserver.typico.com/your GitHub username/your repository, and you'll instantly be able to access your details. Then we're going to migrate our NFT contract, which means writing code that will deploy the contract to the blockchain. You might remember this file we had, initial migration.js, created for us by Truffle. This is the code that deploys the migrations contract. We're going to build our own similar migrations file called anything you'd like, really. This is going to migrate or write the code that deploys our NFT contract. So you can make this file manually or via the terminal. Now, for editing code, it's best to use a code editor like Visual Studio Code, and you will need a Solidity compiler extension as well. So we recommend Visual Studio Code for this next step, which is building the deployment script. So here, this script is taking our NFT artifacts, that JSON file, and it's writing the code that will deploy the contract to the blockchain. So in order to deploy this NFT, we need to pass in a name, a symbol, and then the token URI, the token details. So our name will be Hello NFT, the symbol will be Hello NFT, and then the token details are hosted on my JSON server. So that's why we needed the my JSON server. All right, so that is the code to deploy the NFT. It uses the JSON file, the contract artifacts for the contract, not the Solidity file for the contract. So if you want to deploy a contract, you have to deploy the JSON version of it, not the Solidity version. All right, and again, we can remember that we needed the name, the symbol, and the base token URI because that's what the constructor for the NFT requires. Next up, we can deploy our NFT, but we need a blockchain to deploy it on. So for this example, first we're going to deploy the contract to a local blockchain. That means a blockchain running on our computer. So to launch a local blockchain, we can use the command npx truffle develop. This command is going to open a Truffle console with a development blockchain. So we can take a look here at the results of this command in the terminal. We now have a blockchain running locally on our computer. We can see some test accounts that we've been given with test ether that we can use to interact with the local blockchain. And we have the passwords to each of the accounts. As well, we have the password to the wallet, which stores all the accounts. And we can see in the terminal, we're no longer interacting with our OS, our operating system. We're now interacting with our blockchain because we're now in the Truffle console. So now that we have a blockchain up, we can deploy our NFT contract to that blockchain. For that, we can use the command migrate in the Truffle console. This command is going to compile our contracts. All right, so then it's going to use the migration scripts to deploy the contracts. It's going to deploy our migrations contract, which was just there by default, but you could remove that. And it's also going to deploy our NFT. Then we have the total deployments is 2 contracts and the final cost. That cost was taken from our free testing accounts, so we don't have to worry about using real ETH. And we did it. We deployed 2 contracts, the sample and the NFT. If you want to redo that step, then use migrate again, but use the reset flag to redo the migration. And make sure you're in the Truffle console, not the regular console. Next, we can interact with our NFT on the blockchain. We can use the command await, followed by the contract name .deployed. This is going to make a reference to our deployed contract and save it under the name NFT. You have to wait for the deployment. So initially you'll get undefined because you have to wait for the deployment to complete. Then you can inspect the value of NFT and it will now be a Truffle contract once the contract has been deployed. So that is success. That means we were able to deploy the NFT and then get it from the blockchain. We can also get the NFT metadata. So we can call the contract to read the token metadata. For that, we can use a command like await nft.name and we'll get the name returned, hello NFT. We can also use await nft.symbol to get the symbol of our contract. So this verifies that our contract is working on the blockchain and we can talk to it. We can make transactions to that contract. We can also mint NFTs via the contract. Minting means sending a transaction to mint tokens to a given account, creating NFTs from an account with the minter role. The account with the minter role is the account which deployed the token. So how do we find who deployed the token? We don't really need it, but we can find out who deployed the token. For that, we can use the command nft.minterRole. Then we can call nft.mint. So we're creating a new token. Here we're minting one NFT with the token ID 0. And you have to insert an account to mint 2. You can select any account under those 10 accounts that we were given on this local blockchain. All right, so for example, we can use nft.mint and then use one of the accounts. That means that account will get the NFT. So the minter role is the one that is doing the minting, and the token will be sent to the account that you pass in. So that will be the owner of that NFT. So with this command, we'll get a result of the transaction details if the transaction was a success. So in our case, we got success. We minted an NFT with our mint function. So now we can check the minted NFT. For that, we can call await nft.owner of the NFT at index 0, and we should get the owner's address returned. So that means the owner of the first NFT at ID 0, which is the first ID, it was that address. We can also get the token URI, which means the details for that NFT with await nft.token URI at index 0, and we should get the link to our JSON server returned. Remember, that contains the JSON data describing each NFT, and this one will give us the NFT with the ID 0 because it's the first one. Next, we can set up our project for deployment on a test network like Rinkeby, which is no longer a local blockchain, but it's now global and public. So we can deploy to the Rinkeby public testnet because OpenSea supports Rinkeby for testing. So we can deploy an NFT for free using free or test ether to Rinkeby, and then we can check the results at OpenSea. And you can follow the exact same steps if you want to deploy to the Ethereum public mainnet, but in that case you'd have to use real ether. So we're using Rinkeby because we can use test ether, which is free. So what do we need to deploy and set up our project? To set up the project, we need an Infura project ID. We need a wallet provider. We need to configure our Truffle configuration. We need a funded testnet account. We need some test ether for Rinkeby because for each different network, you need test ether on that network. So I need test ether on my local blockchain, and then I need different test ether on the Rinkeby network. If I want to use Robston network, I have to use ether for that network. Same thing for the mainnet. I'd have to use real ether in that case because the mainnet is a real network, not a testing network. We also need an environment file to store our secret wallet. So let's get started with the first step, how to use Infura. Infura is a blockchain development suite with high availability APIs and developer tools that gives you quick, reliable access to the Ethereum network. So with Infura, we can go to infura.io and get a free project ID. Just create a free Infura account, create a free project, and then copy the project ID. So here is an example of a project. You can go to project settings and then copy the project ID. And the endpoint you can choose should be the Rinkeby endpoint, not the mainnet endpoint. Next up, we're going to get a crypto wallet provider. So what is a wallet provider? Well, with a wallet provider, you can deploy your contract via Infura, and you can sign your transactions. So you can deploy your transactions to a public network like the Rinkeby network, and you can sign them to make sure that they work, and then they'll be sent to the remote public node. So how do we install a wallet provider? Well, first we have to exit the Truffle console, so press Ctrl+C twice. This will take you back to the OS console. Right, so here we're going to go back to the regular console. Then we can use the command npm install Truffle HD wallet provider. This will install an HD wallet enabled Web3 provider. This is a digital wallet commonly used to store digital keys for anyone who owns crypto. And this could be test ether or it could be real ether. You can also sign transactions, which means you verify them. All right, so then we're going to have that HD wallet provider installed in our project. Our next step will be to configure Rinkeby in the Truffle project in truffleconfig.js. So for that, we will have to go into that file, truffleconfig.js, and we'll have to require the HD wallet provider, and then define our mnemonic, which we'll talk about shortly. We'll have to define our project ID from Infura. Then we'll have to add a network to networks. We have to add the Rinkeby network. So if you want to add a network that's anything other than a local network, the local blockchain, then you have to define it. So if you want to connect to the Ethereum mainnet, you have to define it. If you want to connect to Rinkeby, you have to define it. If you want to connect to Robston or Coven, you have to define all those. So we have to define the provider, passing in our HD wallet provider with a mnemonic, and the link to Infura with our project ID. And make sure this is the Rinkeby link, not the mainnet link. Then we have to pass in the network ID for Rinkeby specifically, and some typical amounts of gas prices, confirmations, timeout blocks, and skip dry run. Those are commonly always those values. Okay, next we saw that we had a mnemonic, but how do we get a mnemonic? A mnemonic is a 12-word phrase that the wallet uses to generate public-private key pairs. The mnemonic is how you can log into your wallet. So how do we get a mnemonic? Well, this must correspond to an actual testnet account, so we can get a mnemonic with MetaMask. MetaMask is the #1 software cryptocurrency wallet used to interact with the Ethereum blockchain. You can store real Ether, or you can store test Ether for networks like the mainnet, Robston, Coven, Rinkeby, and even a local blockchain. You can store crypto to interact with all those different networks. It comes as a browser extension or a mobile app, and it's commonly used to interact with decentralized apps. You can buy, store, send, and swap tokens. There's a key vault, secure login, a token wallet, a token exchange, everything you need to manage your assets. It's simple and a secure way to connect to blockchain-based apps. You own your data because MetaMask will generate the passwords and keys on your device, so only you can access them. So download the MetaMask browser extension by going to metamask.io/download and hit install MetaMask. The supported browsers are Chrome, Firefox, Brave, and Explorer, or Edge rather. Next, how do you get a mnemonic? Well, a mnemonic is completely free to get, so in order to get a mnemonic, you have to create your MetaMask account and never share your seed phrase or secret recovery phrase, because that's the mnemonic. The secret phrase that you use to create your MetaMask account, you have to save that, write it down somewhere on paper. That's your mnemonic. Never share that, because if you share that, then someone can access your account, because that's how you access your account. So then take that mnemonic and copy it into truffle-config.js. As well, we'll need some test ETH for the Rinkeby network, because if we want to interact with contracts on the Rinkeby network, then we need some ETH so that we can actually pay for those transactions. You can't interact for free. So how do we get test ETH for the Rinkeby network? Well, Rinkeby is a test network that uses free test ETH only, so not real ETH. We have to add the Rinkeby network to our MetaMask account first of all. For that, click on the MetaMask extension in your browser, and then click on the Ethereum mainnet, which will be the first one listed. Then click show/hide test networks, and select test networks to be on. Then you can select the Rinkeby test network and make sure you're under the Rinkeby test network. All right, so first you'll be under Ethereum mainnet by default, then you want to switch to the Rinkeby test network. So now I'm at the Rinkeby test network. Now how do I get test ETH? Because by default you'll have 0 test ETH for the Rinkeby test network. Well, you need to get ETH for this network specifically. So for that we can go to a Rinkeby authenticated faucet. You can search for a faucet like faucet.rinkeby.io. A faucet means you can request free test Ether. In the terms of the faucet.rinkeby.io, you can use your Twitter or Facebook to request Rinkeby, or create a temporary Twitter or Facebook to request test ETH. There are other faucets out there for Rinkeby, but faucet.rinkeby.io is the most popular one. Don't use other networks' faucets like the Robson faucet or one Robson faucet, because then you will only get the ETH for that network. You have to get the ETH for the Rinkeby network if you're trying to interact with the Rinkeby network. Right, so that's how you can get test ETH. Next up, we have to hide our mnemonic in our Truffle project, because the mnemonic should be kept private by turning it into an environment variable. That way, if you upload your project to GitHub, no one will be able to see your mnemonic. So how do we create the mnemonic? Well, first we can install the .env package. This allows you to create environment variables. Next up, we're going to create a file called .env and enter in mnemonic equals followed by your mnemonic with 12 words, or it should be 12 words. So here is an example of the code that you should have in there. Mnemonic in capitals equals followed by, in double quotation marks, the mnemonic. Make sure these quotation marks aren't smart quotes but are straight quotes. Right, so your mnemonic should be in that file. Then create another file called .gitignore, which will list the files to ignore when uploading this project to GitHub, and add .env as a file in that list of files. Okay, great. Then in truffle-config.js, remove your direct mnemonic constant and instead reference it via the environment variable. So only you will be able to access this variable because only you will have the .env file that shows what the variable is. So you have to first require the .env package to enable environment variables. Then you have to create your variable or constant mnemonic, and it's going to equal process.env at the name mnemonic. Process.env refers to the .env file. Mnemonic refers to that value that you set, that mnemonic equals. Right, so that's how you can reference a mnemonic that is private rather than just putting your mnemonic right here, like this is my mnemonic in quotes. That would be way too public. Then anyone can see what your mnemonic is. Instead, you want to reference it via the environment variable. Right, so here is what your truffle config.js file should look like now. So instead of having the direct value for the mnemonic, you access the mnemonic via an environment variable. That way you can share your project but not share your MetaMask passphrase, which is how you log into your MetaMask wallet. You can also use one MetaMask wallet for testing and one MetaMask wallet for actual Ether if you are worried about losing your MetaMask wallet because you accidentally share your passphrase. Then you could have two, one that you only use for testing, one that you only use for storing your real crypto. Or you can just use MetaMask for testing and only store your real crypto elsewhere. All right, so we have successfully hidden our MetaMask passphrase. Next up, we can deploy to a public testnet. So we're going to deploy our NFT again, but this time not to a local blockchain, but to the Rinkeby public blockchain. So how do we do that? Well, to deploy to Rinkeby, we can use the command npx truffle console network Rinkeby to launch the Rinkeby network. So this way we can connect to the Rinkeby network via our Truffle console. If you get an error message that says the project's unavailable, then restart the terminal application and make sure that your Infura project ID and all the other settings are valid if you do see that error message. Next, we can use the command migrate. This will deploy our contract to Rinkeby. It will deploy the migrations contract and the NFT contract. So again, you could remove the migrations contract if you don't want it bothering you, because it's just a sample. This can take several minutes. Deploying to a public net takes longer than deploying to a local blockchain, because the local one is just on your computer, but the public one is out there on the network. So first, your contracts will be compiled, then the migrations will be started to migrate or send your contracts to the Rinkeby network. The Rinkeby network is a test network for the Ethereum blockchain. All right, so first we're going to deploy migrations, then we're going to pause for 2 confirmations, then we're going to deploy our NFT, and again pause and then complete. Again, that cost comes from our test ether, which is going to come from the Truffle console. If you get an error message about an address not being found, then you can replace the HTTP Infura URL with a WSS Infura URL instead. This is a common problem that can come up if you do see that error message. This is because sometimes Infura can go down the network connection, so you might have to switch from HTTPS to WSS connection if you do see this error message. It is unlikely though. You can check Infura's status at any time by going to status.infura.io to see if all systems are operational or if there's some kind of connection issue with Rinkeby or another network. If you need to make a change to your contracts, then use the command migrate reset to redeploy your contract again to the Rinkeby network. If you get an error message about error while attempting to update the latest block, then just relaunch the network again. Relaunch your connection to the Rinkeby network. That's a common error message that can appear. Great, so now our contract lives on the Rinkeby network, so we can interact with our NFT. Let's learn how we can send a transaction to mint tokens to a given account from an account with the minter role. So we're going to do very similar things to what we did for the local blockchain, but this time we're not interacting with the local blockchain, we're interacting with the Rinkeby blockchain. So we can await for our NFT to be deployed, and then we can inspect the value of the NFT contract. We can also check what accounts we have. These accounts are actually your MetaMask accounts now. These are the accounts listed in your MetaMask wallet. You can check which account has the minter role, and this will likely be one that's not in your MetaMask account, but one from the Truffle console. Then you can mint an NFT to one of your MetaMask accounts, and then your MetaMask account that you pass in will own that new minted NFT. So it's going to mint from the minter role, and it will mint to whatever address you pass in here. All right, so then the result should be the transaction details, the transaction receipt. You can then validate your metadata on OpenSea. First, you can get the address of your contract on Rinkeby with nft.address. This will return the address of your smart contract. Then you can perform OpenSea metadata validation by going to Rinkeby api.opensea.io/asset/ your NFT contract address / your token ID, like 0 if you've only deployed one token or if you've only minted one token. So your NFT contract address is your deployed contract. Then anytime you call mint, you are minting a new token with a new token ID starting at 0, and then you mint again, you'll get token ID 1, then you mint again, you'll get token ID 2. One example here of an OpenSea metadata validation asset is one that I have minted, and you can see the details about the minted token. Is it valid? And what is the token URI? And the token URI should be to your JSON server. Another way to validate the token is to view it on OpenSea. So you can go to rinkeby.opensea.io/assets / your contract address / your token ID, like 0 if you've only minted one token. For example, here is an NFT that I've minted at OpenSea. You can see it's called Hello NFT 0 because it's the first one that the contract minted, so it gets the index 0 and the name Hello NFT 0. So we did it. Our NFT is on OpenSea. Congratulations, everyone. We just went through the steps of building a new Truffle project and then deploying an NFT to a local blockchain and to a Rinkeby test Ethereum network. You can follow the same steps to deploy to the Ethereum mainnet with real Ether. Don't forget to subscribe, like, and comment, and full courses are in the description. If you liked this video, then go to training.mammothinteractive.com. We have tons more content on blockchain, web development, machine learning, and much more. We also have a membership for just $19 a month where you can get access to our 372 course bundle and counting.